Hi everyone, how are you all? I hope you are good. So today we will be solving the question number of 1 bit. It is a very easy question as it is also tagged with easy tag. So let's see what is this question about. Write a function that takes the binary representation of an unsigned integer and returns the number of 1 bits it has. It means we need to return the number of set bits in the integer, which is an unsigned integer, and we know that unsigned integer is it of 32 bits. This is some information written given for Java. Let's see what are the test cases given. So here we are given with an integer n, and here we can clearly see that there are 3 set bits, so the output is 3. In the second test case, we can see that here is only 1 set bit, so the output is 1. And in this test case, you can count the number of ones, which is 31, so the output is 31. So we need to find the number of set bits in an unsigned integer. So let's see how we can approach this question. So for the first test case, we are given with an integer n, which have some leading zeros, and then 1 0 1 1. So basically what we can do to solve this question, like for finding the set bits, we can simply perform the AND operation of this integer with the 1 left shift of 32, like we can run a loop from 0 to 32 so that we can get each bit of this integer and perform the AND operation of this integer with that left shift integer. So let's see what I am saying. So this is our given integer, and here we are performing 1 left shift 0. It means 1 is present at 0th position. And now if we perform the AND operation of this integer n with this 1 left shift 0, then at the 0th index we will get the set bit only if the bit is set at that position in the given integer. So here the bit is set as 0th index in the integer n, and hence we are getting 1 in our result at that index. Similarly, if we do 1 left shift 1, so it means here we have 1 at the 1th index. So if we perform the AND operation of integer n with this integer, we will get the set bit at index 1 only if the bit at index 1 is set in integer n, as we can see here. So similarly for 1 left shift 2, if we are checking for the index 2 whether the bit is set or not at index 2 in the integer n, so if we perform the AND operation of 0 and 1, it will give us 0. So as the bit at index 2 is not set in integer n, we are getting 0 at that index in our output. Similarly for 1 left shift 3, we are performing the AND operation of that integer with 1 left shift 3. So as we can see that the bit is set at that index, so we are getting 1 at that index in our output. Similarly for 1 left shift 4, here the bit is not set at index 4, so we are getting 0 at that index in our output. Similarly for the index 5, the bit is not set at that index, so as a result we are getting the 0 at that index in our output. Similarly, we can do for all the 32 bits in our given integer and find the number of set bits in the integer. So let's see how we can code it up. So first of all, we need to define our result variable, which will count the total number of set bits in our result. Now the unsigned integer will be having 32 bits. So we need to check for every bit whether it is set or not. So we will simply run a loop from I is equal to 0 to I is less than 32. Here now we can check for that integer and perform the AND operation of that integer with 1 left shift I. It means we are checking for every bit, and if this result is not 0, it means the bit is set at that position. and as a result we will increase our number of set bits and finally return our result variable. Okay, so if this value is not 0, it means the bit at that index is set in the integer n, and hence we are incrementing our result, and finally we are returning our result. So let's try run this if it is correct or it is giving some error. What has happened? Let me, oh, I have written I left shift right. Yeah, it was just a typing mistake. Yeah, let's try submitting this. Yeah, so now let's talk about its time and space complexity. So as we can clearly see that we are running only one loop from 0 to 32. So its complexity will be 32, and as 32 is a constant number, so we can say that it is running in O of 1 time complexity. And talking about its space complexity, we can clearly see that we are not using any extra space, so its space complexity will also be constant. Yeah, I hope you get this question. It was a very easy question. Thank you for watching this video. Bye bye guys. See you soon with the next video.